Hello students, today we are going to discuss about the chapter number 3 electrochemistry. Topic is variation of molar conductivity with concentration and KOHLRAUSCH'S law. So these two topics we are going to take up. So let us start our session with a very good thought. Success is not the key to happiness. Happiness is the key to success. If you love what you are doing, you will be successful. So the meaning involved here is, so whatever you are doing in your life, you should love it. Then success will come automatically. Okay, let us start the session. The learning outcomes are variation of molar conductivity with concentration for strong electrolyte and weak electrolyte. You will be able to explain that. KOHLRAUSCH'S law, applications and numericals on KOHLRAUSCH'S law. Okay, let us start. So why we are studying this? Because KOHLRAUSCH'S law helps us to find the molar conductance for weak electrolytes at infinite dilution. This is the practical application of KOHLRAUSCH'S law. Determination of degree of dissociation of a weak electrolyte alpha. Similarly, determination of solubility of a sparingly soluble salt. We are not able to find the solubility of sparingly soluble salt, but by using KOHLRAUSCH'S law we can find out. So molar conductivity versus concentration. What is the relationship that we have to discuss? That will be divided into two parts. One is strong electrolyte, second is weak electrolyte. Strong electrolyte means to say that when strong electrolyte is dissolved in water, it will give two ions. Complete dissociation of ions. KCl will give K plus and Cl active. HCl will give H plus and Cl active. So molar conductivity decreases slowly with the increase in concentration, or opposite. If concentration is decreased, molar conductivity will increase. For a weak electrolyte like acetic acid CH3COOH and ammonium hydroxide NH4OH, the molar conductivity decreases with the increase in concentration and increases exponentially when concentration is decreases to infinite dilution. The same thing, if you are decreasing the concentration, the molar conductivity is increasing. So let us see and explain with the help of a graph. So this is the graph for strong electrolyte like KCl. If you see, if concentration is 0.1 or 0.2, that value is molar conductance is less. If you are decreasing the concentration, the value will be more. If you see, if I will cutting the graph here, the molar conductance will be nearly 250, let us say, and if it is 0.1, it will reach to 280. So this is the meaning that if I am decreasing the concentration and the molar conductance will be increasing. Infinite means it is dilution. Water you are adding, infinite dilution. Okay, so let us see this graph also. This graph is for weak. Here this graph, exponential curve. So what is there? If concentration 0.4, if you decrease the concentration 0.2, it increases. If you further decrease, what is happening? It is infinitely increasing and parallel to the y-axis, that is concentration, the molar conductance. So what I want to say is, if I want to find the molar conductance of acetic acid at particularly this concentration, we will not be able to find it. The curve will not intersect and you will not be able to find. So how to find? We have to use KOHLRAUSCH'S law, and you see that KCl, this is the graph between KCl, molar conductance, and C under the root C, that is under root of C. Okay, so now KOHLRAUSCH'S law, we have to find the molar conductance of weak electrolyte like acetic acid. We cannot find as such because the curve is getting parallel to y-axis. So then we have to use KOHLRAUSCH'S law. What it states? KOHLRAUSCH'S law states that in an infinite dilution of an electrolyte is equal to the sum of molar conductances of its cation and anion, with each conductance terms multiplied by the number of respective ions present in the formula unit of the electrolyte. What it means? Acetic acid will give ions CH3CO negative plus H plus. May not be completely dissociated 100%, maybe 30%, 40%, 50%, 20%. Barium chloride will give barium ion and chloride ions. So KOHLRAUSCH'S law states that whatever the ions are given, how many number of ions are given, multiply with that, it will give the total conductance. Like total conductance, molar conductance of acetic acid at infinite. Here infinite means it's a very dilute solution. That is equal to molar conductance of individual ions. Individual means acetate ions and H plus. Now here 1 is there. Acetic acid will give 1 acetate and 1 H plus, but barium chloride will give 1 barium ions and 2 chloride ions. So multiply by 2 is there. This is the meaning. Okay. So now, the applications of Kohlrausch's law. What is that? Determination of molar conductivity of weak electrolyte. For example, let us discuss with the example. If you do more numericals, then it will be more better for the understanding of Kohlrausch's law. So calculate the molar conductivity of acetic acid in infinite dilution, because we cannot find. Now here we are finding through Kohlrausch's law. If the molar conductivity of NaCl, HCl, CH3, CONA are given as below. So now what we have to do? So you know that Kohlrausch's law states that the total molar conductivity of acetic acid will be equal to ions. So what I am doing? We know we have been given for sodium acetate. We have been given for HCl. What I will do? I will add these two and minus NaCl, because Na is extra here, Cl is extra, so minus NaCl, because we are able to find for this sodium acetate and we are able to find HCl. Why? Because these are strong electrolytes. Strong electrolyte I can identify. I can find the molar conductance, but for weak electrolyte is not possible. Therefore, I am using Kohlrausch's law to deduce the molar conductance at infinite dilution of acetic acid. Okay, so what we have to do? Simply substitute the values. So 91 plus 426 minus this. So units you should be careful. Ohm inverse, centimeter square, mole inverse. That is molar conductance units. Okay, hopefully you have understood. So let us see. Now you can try that numerical, so that this way also you will be able to know. So that this is aluminium ions and sulfate ions. Okay, so this is the what Kohlrausch's law states: the number into the individual ions contribution, number into individual ion concentration, conductance. Okay, so unit same, ohm inverse, centimeter square, mole inverse. Okay, now, so next application for Kohlrausch's law is determination of degree of dissociation of a weak electrolyte. Now this question is very important. It has been asked a number of times in the exams. Specific conductivity of 0.1 molar NH4OH, ammonium hydroxide, is a weak electrolyte. Specific conductivities. Always check the units. Then you will get some idea that what we are going to explain. Here unit is supposed to be specific conductivity. I think is error is there. Ohm inverse, centimeter inverse will come. Okay, the molar ionic conductance at infinite dilution for each ion, ammonium ion, hydroxyl ion, are this. Calculate the molar conductance of the solution, degree of dissociation alpha, and dissociation constant of base Kb. So what do you have to find? We have to find molar conductance of the solution. It's so easy to find out. Molar conductance is equal to kappa. Kappa is specific conductivity. So I would like to repeat once more that this 3.6 times 4 minus 4 unit is ohm inverse, centimeter inverse. Not this is a small error is there. So you can see here it is rectified. Ohm inverse, centimeter inverse. This is specific conductivity kappa. And you know molar conductance is given by this formula, kappa into 1000 divided by molarity. So we have been given each and everything. So we are finding molar conductance at C concentration. For infinite you have to apply Kohlrausch's law. So Kohlrausch's law states that each ion contribution into 1 into 1. So total is 251. So which is more? Infinite is more. Why more? Because concentration is less. We know concentration is less, molar conductance will be more. And degree of dissociation formula is C by infinite, means this molar conductance C and divided by infinite, that is 3.6 divided by 251. So we are getting 0.014 and Kb C alpha square by 1 minus alpha. This is as per Ortswald dilution law, plus 1 you might have done, and C alpha square 1 minus alpha, 1.98 times 4 minus 5. So this is the way we can solve the numericals on Kohlrausch's law. So next is determination of solubility of a sparingly soluble salt like HgCl, barium sulfate and lead sulfate. These are sparingly soluble salt, means poorly soluble in water. So how to find is molar conductivity of saturated solution? We can find out, and that is molar conductance at infinite dilution, because it is very dilute. Otherwise, how the substance will dissolve? And this is how we can find is kappa salt is equal to kappa saturated solution minus kappa water. So water we are moving that. And then kappa salt into 1000 divided by molarity. Molarity is the solubility in moles per liter. Solubility will come in moles per liter. If you want in gram per liter, so then you have to multiply by the molecular mass also. Okay. So normally these numericals are not coming. Now what is the summary? Whatever the topics we have discussed till now, that is equivalent conductance and molar conductance. Equivalent conductance and molar conductance of equivalent conductance and molar conductance increases on dilution or with the decrease in concentration. So as the concentration is decreasing, dilution you are doing, equivalent conductance is increasing. As per Kohlrausch's law, the molar conductivity of an electrolyte is equal to sum of the molar conductance of its cation and anion. Each conductance term multiplied by the number of respective ions present in the formula unit of the electrolytes. So further we have done numericals on that. Okay. So hopefully you might have understood all these topics which we have taken. So I would like to repeat the thought: success is not the key to happiness. Happiness is the key to success. If you love what you are doing, you will be successful. So follow this thought and implement it in your life. Thank you very much for your patient listening. Thank you.